thanks everybody for being here with us. This is going to be a fun, interesting, and hopefully very productive webinar. The Mobility Frontier exists to bring together panelists from all over the world, as we are going to see today, and also to bring expertise that touches mobility from different levels, always trying to bring something new, but also input to unsettled topics that we still don't have definite solutions for. So that's basically what we're doing today when we talk about what happens when auto, aero, and commercial vehicles converge. And for that, we have three excellent panelists that I will introduce quickly. They will introduce themselves. And these are people that have contributed to the mobility industry for a long time. Sven Beiker from say passenger from the passenger automotive sector. Then we have Samir Khan from the aerospace industry, and Sylvia Iombriller that is from commercial vehicles. So please, let's start with your introductions, and then we're coming in with the questions. Sven, please.
Sure, I'm happy to. Thanks, Monica, for the brief introduction and also for inviting me to be here on the 10th episode of Mobility Frontier webinar. Sven Beiker, automotive engineer out of Germany. I've been working on vehicle dynamics, active safety, and automation systems basically throughout my career. Started at the German automotive industry at a vehicle manufacturer, then turned into an academic at Stanford University, and now I am an independent consultant where I work with my clients in the mobility industry to basically find out the roadmap towards more sustainable and safer vehicles, to manage partnerships that are obviously more and more important as we are working on the mobility frontier, and also to do here and there some professional development courses with my clients or my students at the university. And good to be here
Yes.
on the stage.
Hi everyone, my name is Samir Khan. I started my career as an academic in the UK at Cranfield University, and my primary research was basically working with a number of aerospace organizations, investigating maintenance issues. I've kind of progressed since then. I moved to Japan to work at the University of Tokyo, again as an academic. And I was mostly managing a research lab over there, looking at spacecraft systems and designing health monitoring systems for spacecraft. And this is an interesting project because it gave me a lot of opportunity to work on artificial intelligence and onboard computing and a lot of these problems that the space industry is currently facing. At the moment, I'm currently engaging with some work with the University of Tokyo as well, in terms of satellite development. But I'm also working at Cranfield University as an academic. So I do move around between the two, whilst I'm primarily based in the UK, but I do have quite a bit of work going on in Japan as well. So I'm looking forward to this discussion. Thank you.
Yes, thank you. Thank you. And Sven, you're talking to us from Austria, right?
That's right. Yes.
Yeah.
I am based in Silicon Valley
Mhm.
usually, but I get to travel to Europe quite a bit. And yes, I'm happy to report that right now in Vienna, Austria, where we actually have the SAE Vehicle Automation Symposium. So this afternoon, been talking a lot about robo taxis and regulatory things around automated vehicles, standards, of course. So yeah, I'm currently on an SAE mission, which is part of my, let's say, summer trip here in Europe. So it's one stop
Thank-
on my journey.
All right. So, with each one of you coming through, from one specific sector, right? Automotive, light duty, commercial, and aerospace. Uh, they have been considered independent industries. Yet we see that multiple new technologies and more
Mhm.
seem to be applicable to all of them. Cases to be mentioned: autonomy, AI, electrification. So these are just some examples that we see every day. Do you see this as a more permanent trend? If so, why?
I know, Samir, do you want to go first?
So, yeah, thanks for the question, Monica. I do see a lot of overlap in terms of capability, need for capability. So things like autonomy is a desirable capability, not just in aerospace, but also in automotive. There's an awful lot of work that is being done to make sure that the cars can drive themselves. But at the same time, it's just the scale of a lot of these systems have grown really big. It's very difficult to maintain everything safely just by a few humans. And hence, they would prefer offloading a lot of these um, requirements onto software defined technologies that will monitor, that will manage a lot of these systems autonomously, whilst providing the human with some input that is desirable for what they want. So I think there's a lot of overlap going on between the different industries. One industry might be leading a little bit more in terms of standards, whilst the other one might be leading a little bit more in terms of innovation. And again, it's just about how fast these different industries might share ideas and converge to a single point. I think that's what I think the direction the research is going into, at least.
Interesting, because we have some questions about that too. So, Sven, what's your take on that?
Yeah, well, I definitely agree with Samir. I mean, there's a lot around automation where we see that the aerospace or the aviation industry is really being looked at by the automotive sector, especially when it comes to safety, redundancy, uh, and protocols to follow to make sure that we have safe systems on the road. Um,
Mhm.
because obviously safety is primary thing for flying, because you cannot just stop midair and look under the hood, but also it is obviously very
No,
important.
you cannot. You should not.
At least you shouldn't, and you only have maybe 20 seconds to check. And but also on the road, obviously, safety is of prime interest. So that's all. But I will say, I want to add, Monica, I want to challenge a little bit your introduction there, because the way how I understand it, that this is a new trend, and
Mhm.
I maybe
Yes,
want to add, if you allow, that this is
of
not
course.
exactly new. So I've been
Tell me
working.
more.
Yeah, absolutely. I've been working quite a bit, and I also wrote about this in my book, The Mobility Diaries, that I published with SAE some 2.5 years ago, about ABS, like anti-lock brake systems. They were first introduced in aircraft in, I want to say, around the 1940s or 50s or something like this, and they found
Okay.
entry into passenger vehicles and actually light commercial vehicles as well in the late 60s and then 70s.
Yeah.
And another thing, if you want, like, let's say, what sounds today mundane, like a hydraulically assisted steering systems. They
Hmm.
came basically out of servo systems on aircraft, first into commercial vehicles, because in order to turn the wheels on a commercial vehicle, high axle load and everything, you needed assistance. Later on, then also on passenger vehicles. And guess what? Diesel engines, yeah, they still exist. Not everything is 100% electric. Diesel engines were first used on commercial passenger vehicles. So there has always been cross pollination, if you will, between those sectors. But I will say, with what is happening right now, regarding automation, that is accelerating, and it's probably more getting more deeply intertwined. And for AI systems, I would say there's a lot of mutual consideration where maybe the automotive industry, because safety is not exactly the same as on flying vehicles, where maybe the automotive industry is a little bit ahead with AI, and I'm sure the aviation sector is watching this quite closely. So has been something for decades for all the right reasons.
Right. And Samir, do you have anything to add to that before I go to Sylvia? Because she comes from commercial vehicles. I'm sure there is something new there too, and there is a connection there that we should explore.
I think no, I think one of the issues that I've come across, and I've seen it a few times, is essentially the different engineering approaches that we often use, even if we're designing, for example, if we're trying to develop AI systems in aviation, you will have many engineers who have been trained to develop their systems using something called the V model or the waterfall model and different types of approaches. And they try to design a lot of these systems using the same traditional engineering approaches. And after a while, they realize, well, it might not be the best way to implement something. I'm sure the automotive industry is also using something quite similar. And if
Absolutely.
you've come across any this.
The V model is big in the automotive industry, and I do know that it's been applied outside the automotive industry, apparently in the
Yeah.
aviation industry. So another great example. Good point, Simone.
Yes. So let's ask Sylvia. Sylvia, I think you're all set now, right?
Yes, sorry for this problem with my microphone, but I think that now works well.
It's okay.
Okay,
No problem.
okay,
Sylvia, give us a brief introduction of yourself and we'll
for
dive
sure,
right on to the conversation.
sure. Well, I hold a PhD in brake system for commercial vehicles from the University of São Paulo, despite initially I having graduated in aeronautical engineering. I
Yeah.
have 30 years of experience in the automotive industry, with 22 of those years at Ford Motor Company. And currently, I lead the brakes and suspension engineers teams for commercial vehicles in North America. And I'm really involved in SAE and in several areas. And for more than 10 years, I represented Ford, leading the review of brakes standards and regulations in Brazil. And
Mhm.
since 2015, I also taught as a professor at the Mauá Institute of Technology, and I can discuss a lot of things similar to this that we are discussing today with my team and with the guys that try to understand better this challenge that we have to do in the industry. Okay,
Right. Very
and
good. Thank you. Yes, please
thank you
go ahead.
for invite me, and it is a pleasure to stay here with you. Okay.
Sure. Thank you. Thank you for being here. So the
And
conversation basically is how we think that the commercial sector, the commercial vehicle sector, aerospace, and light duty vehicles tend to have their own lanes, right? They develop things separately. And what both Sven and Samir are saying is that not so much, that actually there are things that are common and used in by the three sectors. What's your experience with that?
I really think that we don't have uh, these walls, uh, this difference between these sectors, these areas. But we have something that's specific for each one. As well, we know that we have specific customers and the specific applications for that. But I really think that we have some base and some basic knowledge that's common for everyone.
Mhm.
And one of that I can listen you and I can list some examples from Sven and Samir, and I agree in totally. And the developed methods, we have a similar one, and I can compare. For example, we can use the same one to develop cars and commercial vehicles, but we know that we need to adapt some parts of that because we have times and the rules and the requirements totally different. But for example, I would like focus in another one that I think that's so important. That
Okay.
is the quality tools usage. We can use the same quality tools to develop different areas of mobility. And I think that the term mobility is something very good to use because when we create this term to use mobility, we talk about everything that can move, and it involves cars, trucks, and planes. And
Yes.
this is the idea that we have more things in common than differences, and it's
Yes.
interesting.
Agreed. Agreed. Yes. Very good. So, from a technical development perspective, what is the common thread that is starting to be visible in these sectors? So, did all our R&D departments start developing similar solutions by chance? Or is there a push for certain capabilities to be found in new vehicles, ground or not? Samir, what do you think?
Okay, so from my point of view, what I've seen is there's a big drive towards software, where software is playing a much more prominent role in terms of whatever technology you've been developing. So you are designing hardware capabilities which might be modular, and you would uh, continue to provide a service based on software updates. So they are not trying to sell you the hardware anymore, whether that be in aerospace, whether that might be in automotive, and Sven can probably elaborate on this. But from what I've seen, is that there is a lot more emphasis on um, as a service platforms, which will be developed, which will continue to evolve whilst using the same hardware. So it's important for the hardware to be flexible. I think that's a sort
Mhm.
of a drive at the moment that I've come across mostly.
And
Yeah.
you see that in the aviation sector too?
I've seen that in the aviation sector, and I'm seeing that in the spacecraft industry as well right
Mm,
now. So
mhm.
spacecrafts traditionally use very um, I wouldn't say very old, but very simple and straightforward technology, which requires minimal maintenance. But even now, the way, because of privatization in the space industry, they are moving towards this idea of having the same hardware, which might be flexible, which you might be able to reconfigure to a certain extent. But a large part of this, I would say almost 70 to 80% of the development costs are actually going into the software that's going on.
Wow, interesting. Very interesting. Sylvia, do you see the same in the commercial vehicles?
Yes, something similar, but I really think that this trend is not happening by chance. I really
Not
think that
happen by
it's
chance.
intentional. Yeah, it's not happen by chance.
Mhm.
It's really something intentional because uh, all of us we have all of us are becoming smart tech dependent, and we
Mhm.
need all these kind of technologies to work today. And
Okay.
I really think that we can, if we think that this kind of technology could be developed and so as something open, and we can tailoring this to our application, I think
Okay.
that we can save money and time for that.
Right.
I really think that is more difficult. Think that I will develop a specific AI to work with commercial vehicles, but I can use the AI that was developed and is open for every kind of transport, and
Mm-hmm.
apply it for my area. I think that's
Right.
the better way.
Okay.
And we
Yeah.
started to do.
Yes. No, agreed. Sven, your
Yeah,
input.
definitely. I mean, what my two fellow panelists here already pointed out. I mean, had we not introduced this as this is an aerospace perspective and that is a commercial vehicle perspective, I would have said, yeah, sure, they are talking about my quote unquote sector, the passenger vehicle sector. Where we're talking a lot about the software defined vehicle,
Mhm.
SDV, software defined vehicle, which is exactly what Samir pointed out, where there's hardware that is not negligible. It is still important, and that's what I always like to say. As long as we are talking about the transportation of physical goods, whether that's people or packages of goods or
Yeah.
what have you, we do need mechanics. Period.
Yes.
But
Hmm.
that is, as Samir points out, and Sylvia was also alluding to some extent, it is becoming more modular and flexible in how you use it because it is now all electronically operated and controlled. And that means software really can define the functionality and the way how you operate it much more. So that for sure. Also,
Hmm.
what Samir pointed to is like as a service, whether that's a mobility as a service or transportation as a service or probably aircraft as a service, truck as a service, what have you. So that is quite interesting how much their technology and engineering aspects actually pave the way for new business models where
Right.
I as much as I understand and curious to hear from Sylvia maybe where I understand in the commercial vehicle sector you are to some extent purchasing the miles and not the vehicle. So where it is something that you basically then just pay when you drive actually that vehicle and not just you purchase it at the beginning. And also related condition based maintenance. Which comes from aircraft. Typically, aero engines are mentioned there a lot, and I know that it's very established in commercial vehicles as well. So another software which becomes the business model aspect. And I guess what unites also all of us is that we are just figuring out how are we going to integrate AI. So there's definitely a
Yeah, that's a big
cross-cutting
question.
thing, I guess.
Yes. Yes, definitely. So since you talked about maintenance, one of the questions that we had here is that in the past 10 years or so, or even going back further, we have been following the development of preventative maintenance for vehicles in general. Um, Here at SAE, we had a series of books on this, and under the basically the major title of integrated vehicle health management. But this was specifically for aviation, aerospace, but we're seeing this more and more trickling down to ground vehicles. So, in simple terms, looking at components and systems, the idea is to try to really follow their performance over time and over circumstances, usage, so that if and when they break, they don't break catastrophically. They don't stop a vehicle from being used. So it's basically to get vehicles to be more reliable longer.
Mhm.
So are the three sectors looking at this the same way? Sylvia, what's your take?
I really think so. But I can provide some examples in terms of commercial vehicles.
Okay.
Uh, First of all, we already learned about our body and mind that preventive maintenance keeps us healthy, and for vehicles, it's the same,
Okay.
right? We needed to work on that, and it is the reason because we call it vehicle health management.
Hmm.
Great. But in terms of commercial vehicles, we have huge benefits. Okay, for example, we can have a fleet management system, and it could include not only the vehicle, but the logistic companies too. And it's
Okay.
interesting because we can control not only the road, but the fuels, the brake wear, tire pressure, everything that we needed to control during this road. And it's very interesting because sometimes to prevent some kind of failure, we do some kind of over maintenance that is replace a part before, but to prevent some kind of failure during the travel. In another hand, we can have under maintaining, and it's not so good. We can have some kind of potential safety issues, and
Hmm.
especially when we involve a big truck. And we in general, we put in the owner manual some recommendations to maintenance. But if you can control and understand and use all this data that we have today to understand which kind of road, which kind of application, how this driver use this vehicle, it will be better. We can define that maybe we don't need to change the oil every 500 miles sorry, 5,000 miles. Maybe we can change it for another instance. Same idea about the brakes. Maybe we can use the vehicle and change the brake friction material after the period that we consider that is a recommended one, but we have different conditions that was driving this vehicle.
Right. And
And
we had talked about
certainly
this. Right. We had talked about this, and you seem to think that uh, the real advantage of this is not about one vehicle, it's about the fleet, where you
sure
really can have
the
savings
difference. Yeah,
and make a difference. Yes.
And
Yes,
if
definitely.
I can add to this, that I would say is a difference then to passenger vehicles, because
Okay.
passenger vehicles, typically we see them, and the majority of them are individually owned and operated. That means you have your personal vehicle that you are taking
Yes.
care of. Whereas commercial vehicles and aircraft are typically fleet operated by a somewhat centralized owner operator. Uh,
Hmm.
it's not always true, but directionally it is. And therefore, again, it's the passenger vehicle industry that now starts to benefit from these condition-based maintenance and preventative maintenance approaches, whether that's through advanced analytics, AI, IoT, what have you. That might be not right there at the cost advantage for an individual owner of a vehicle, or an owner of an individual vehicle, I should say, as opposed to an operator of 10, 20, 100, 1,000 vehicles, where that is very different, because you typically also then need the infrastructure in terms of server space and um, network connections and what have you. But that is, I think, a very important aspect of it, where we like to think of our personally owned automobiles as the marvel of technology, but much of this actually comes from those other sectors, and quite often also because the economics are different there because of the operating model.
Absolutely, yes. Samir, um, just to continue this conversation, when IVA Jam started becoming, a full body of knowledge, the main issue was, okay, we can do all this. How can we tell operators and even OEMs to start using this soon enough, even in the design process, so that when you have an aircraft that is new, which sometimes takes 20 years, that the stuff is already there?
Yeah.
What do you think?
No, you're correct. And I think these types of technologies, even IVHM, a lot of health monitoring technology, is actually quite old. It was developed again in 1950s or even before that. And it took a number of years for it to diffuse itself into regulation, into design of aircraft systems. I think a lot of this was driven by standards.
Hmm.
Eventually, they realized as aircrafts were getting bigger and bigger, I think it was the 747, which was a really big aircraft. And when the maintenance of this type of aircraft came into being, they realized, well, we need something which you will be able to collect the data that is required to enable that the maintenance of such a big asset. And hence, various committees were established, various discussions took place, and certifications were brought in place. And we've seen these certifications kind of overlapping with other industries now, where IVHM is a much more established field. Data has become a lot more important, and it depends on what type of data you're collecting, and how are you applying this data. So
Right.
we've got regulations, we've got standards, and it's just about how you can apply some of these guidelines within your industry, and how you can, if you're in the civil space, how you can reduce your costs, and if you're in the military space, how you can make sure that it's mission ready.
Yes, very much so. And if you're in the commercial vehicle space,
Mm.
that your truck's not stopping all of a sudden in the middle of the road with very precious cargo on, right?
Yes, I in terms of that, I think that's not regarding save money. It's about safety, because sometimes we have two two 2,000 of kilometers to drive, and in
Mhm.
parts of this way you don't have a good dealer to solve some problem, and it's not
Mhm.
a safe place to stay with your cargo.
Yeah,
And
that's
certainly,
right.
if you can predicted it and work previously, it's better and safer.
Definitely. And for us, Sven, who drive our own vehicles, when a vehicle breaks down, it is a problem, isn't it?
Oh yeah, of course. I mean, it always is, and there. I do want to point out maybe a little bit the differences then to the commercial vehicle sector, whether that's commercial ground vehicle or commercial aerial vehicles. With individuals, it does become a different thing, and I don't want to say more complicated, just somewhat different, and others
Mhm.
might decide what is more difficult than others. So there's data privacy and
Yes.
certainly cybersecurity, which I would think are somewhat similar between the sectors we are discussing here. But with data privacy, it does become something like, well, I'm an individual, but I had no idea that this vehicle manufacturer is basically looking into my data and so on. Where you can say, well, that's the same with a fleet operator, but mind you, with fleet operators, whether that's flying or driving vehicles, you can assume, generally speaking, a bit more expertise than with all the individual customers that you might consider for personal vehicles, where basically you have to assume that these are lay people. Like,
Right.
what do I know about privacy, right? I mean, I have my
Mhm.
smartphone and I try to adjust the settings um, to the extent of my knowledge, but I'm not a commercial operator, and so that's what we need to see there. And also, Monica, as you're pointing out, it's not a good day when your personal vehicle breaks down, but it might be even a worse day if you get someone to fix your car, but then it does become something. Oh, the person or the garage, the roadside assistance that you called, is not able to access that data because it is
Yes.
not allowed to do this or something. So certainly with all of this, we're looking into new business models, new usage models, new access and privacy models. Where again, we are looking at the other part of the industry. I understand that commercial trucks have been condition-based, monitored, and to some extent being on a trucking as a service model and so on for quite some time. And so we're definitely looking at it. What can we leverage there in the personal vehicle space?
Absolutely, yes. Now I have a question to all of you, obviously. Um, how will AI play into this? Can you really help? Or is it going to be a problem? Or so what? I think that Samir wrote an edge report about the hype of AI and what the technology really means, at least for now. Samir, would you like to start?
So I think this is a really good question in terms of how far we can take the capability, in terms of what it claims that it can do, and what we can actually use it for today. There's a lot we can do with AI. Let's be very honest about it. There's a whole list of applications which were just not possible 10 years ago that we are able to do right now. And large language models is just one example of that. However, from what we've seen is that um, testing AI systems to the point where it can be used for maybe aerospace industry, um, it's a challenge. And it's a challenge because of various reasons. One of those reasons is that if something is safe and it's been certified safe for a number of years, and then you're introducing the system, which might be black box in nature, and by black box, I mean the way the system was designed. If you redesign the system, the weights of that algorithm might be different, which is why
Yeah.
there's no explanation around why the AI algorithms performs in a certain way. It's very difficult to put it through certification
Okay,
and approval. If it cannot be certified, if it cannot be approved through a particular standard, it can never be commercialized to a certain extent that it will be used on an aircraft or any other vehicle that is safety critical. So I
mhm,
think guys had this challenge. They've been working towards something called explainable AI, which makes it more interpretable. A very good example of interpretability, um, the best way I can describe it is, for example, if you're using ChatGPT and you can tell it, can you explain the reason why you've come up to a certain decision? It can
I
actually
see.
and explain certain actions on why it's come up to that particular conclusion. They don't reveal the whole mechanism behind it, but it does tell you to a certain extent on how it's come up to that conclusion. So it's an ongoing problem. There have been some developments, but I think from a commercial point of view, we still might be um, a, a bit. We'll probably need to wait a little bit before it can satisfy all the safety critical standards or
Right.
requirements.
No, understood. Understood. Sylvia, from your perspective, what do you think?
I really agree with Samir. We need the more robust rules and requirements for that. We can start to using in our process development to accelerate a lot of things, to manage and analyze a huge amount of data that we have, to do some predictions in special in case of commercial vehicles in part lifetime. It's interesting working to understand better this kind of predictive maintenance, the real-time alerts that we can do to customize a lot of things in commercial vehicles, and in special to faster problem solving. I think that we can use. But for some applications and for the interaction with our customer, we need to take care about that.
Mhm.
We need to understand that we really have safety conditions and with a robust regulatory based for that.
Right.
Certainly, we needed to understand. I talk about that in my house last weekend. That it's interesting because AI is a guy that had a lot of teachers, and but we need to take care about the teachers, introduce
Yeah.
all knowledge to this AI.
Yeah. No, that's a good example. Definitely. Yes. And Sven, you are in touch with a lot of different OEMs and
Mm.
suppliers. What what is the take of the industry from the light duty
Yeah.
vehicle in AI?
Well, quite frankly, I could answer this question quite easily by just reading some great comments here on the chat. So I
Hmm.
see that John Otto really has great thinking there, and also Sarui Buzian. Hopefully, I pronounced that correctly. If not, I apologize. But the answers are there in the chat. So for one, safety must never be compromised, and that's also what Samir and I think Sylvia alluded to. And that is actually where in the light duty vehicle field we certainly separate those two parts, like in general terms. Is it safety critical or not? So
Hmm.
if it touches your brake steering and things like that, then AI is much more difficult to integrate for the reasons that Samir basically explained, which is if you cannot explain why it does what it does, then especially the traditional industry has a big concern for all the right reasons. And I say traditional industry, I'll talk about the newer industry maybe in a minute. But the other side, besides safety critical, is like infotainment. I
Hmm.
mean, hey, some people want to have a conversation with a car. Like, hey, I'm driving by this landmark. Tell me something about it. Or natural language with your navigation systems, which is obviously not new, but it is getting better and better finally. And that is all AI driven these days, and that is
Hmm.
obviously not safety critical if that system has a problem because I speak with an accent. Okay, so be it. It might guide me to the wrong destination, but it's not driving me over a cliff at least. So we need to separate out these things. Definitely for non-safety critical, AI is, I want to say, taking center stage in the light duty vehicle field. For safety critical aspects, very different. But also Sylvia made a very important point, and that's also what John Otto, I think, here alludes to: data mining and trending. So in the product development process, which is something that I'm researching at the Swedish university I'm working with, how can you improve the product development process with AI? And
Okay.
a lot like coming up with new ideas, market research, trend scouting, simulation testing. In the latter, you should not completely rely on it, but definitely, if what's pointed out here in the chat, data mining, to really find the needle in the haystack, that's something where AI can probably help, like tell you,
Can be
look at
helpful.
this. That's really what stands out here. Now, that's
Yeah.
all about the traditional industry. Let me just say a few words about the
Sure, sure,
advanced
sure. Please go ahead.
industry that I observe a lot in Silicon Valley. There's much more of an openness also to use AI for, let's say, mission critical and potentially safety critical systems. And this is where we need to see what is the right approach. I do pay attention to statements that say the traditional industry is too conservative, is too hesitant, therefore will not make progress fast enough. but also what Silicon Valley likes to say, move fast and break things. It's not so great if actually there are lives at stake. So this is what we need to figure out for AI. What is the right amount of AI to be considered, depending safety evolved or not?
Right, right. And to your point, there was, yes. So here there was a question that came through the chat. How do we ensure the robustness and honesty of AI when used in support of certification activities for critical safety systems in aerospace and automotive, which to a certain extent you guys already touched upon. But um, I, 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 I I don't know. It piqued my interest when this person said honesty of AI. Samir, what do you think of that?
It's a difficult question, because the reason I say that is because how do you define honesty to your AI system? How do
Mm-hmm.
you know it's going to be fair when it comes up with the conclusion? One way in which you can do this is by providing it with a lot of data. But again, that data needs to be at a certain level in terms of its consistency, in terms of its diversity. Um, it's we can, from what I've seen, is we can follow traditional testing processes that have been defined in certification within aerospace, and then we can follow some of these rules when we're testing these AI systems. um, but in terms of honesty and trust, I think it still is an open question. Even from an academic point of view, it still is something that the software computing science community is still investigating, let alone the engineering community trying to implement something like that. So I think there's still a way to go. So it's a good time to be a researcher right now if you're working on these types of topics.
Yeah, yeah. Sylvia, what's your take? I mean, how do you put boundaries in this? What is honest and what isn't honest in AI?
Um, I really think that it's a good question, and we need to work a lot to have the right answer for that. But I think that a good way to start it, as in my point of view, my simple point of view, that AI was prepared by a lot of teachers. We needed to prepare better these teachers.
Mm-hmm.
We needed to work to prepare better new professionals. We needed to increase a lot of capabilities for that. And the truth is something that's included on that,
Right.
because we needed to have a root ethical on that. When I think about the rules and the requirements for I remember when we started to discuss rules for internet. Did you remember?
Mm-hmm.
And we discussed a lot how to use this new technology, this new tool
Uh-huh.
that we had in our hands.
In
And
terms of trust, maybe in
yes,
terms of trust.
exactly, in terms of trust,
Mhm.
in terms of ethical usage, and in safety too.
Right.
And I think that we have in our hands this kind of discussion more one time. And I think that it will be more common in the next years.
Yes.
And we need to prepare people for that. I
Right.
think that our bigger asset in our companies, in our universities, are people. And we need to focus on that.
Right.
Prepare people to be good as human, as with soft skills and technical skills to
Is
support.
skilled as well. Yes, definitely. Sven, your take.
Yeah, absolutely. Great that Sylvia basically building a bridge from AI to people, if I understand that correctly, and how much people matter. And in that, I want to say or highlight two things here. For one, what we really need is people that actually monitor and judge and check for plausibility what AI does. So if something comes out of an AI system, don't just take it at face value, but
Right.
make sure that it actually is plausible. And that is the same, for instance, at least when I went to engineering school now some 35 years ago, that we learned to calculate when a metal beam might break because it's bent too much, and we could calculate when it breaks. I'm not sure if that's still being taught in engineering school, maybe the very basics, but probably not to the extent that we learned it. Or let's say flow physics, like what is a laminate versus like turbulent flow, and all of these things that we probably
Right.
all of only to then basically have these simulation programs later on in the product development departments, where we could at least then check the results from a deterministic simulation model. Now we are moving to heuristic, meaning probabilistic and AI driven models. And again, we need humans that can check this. I'm not sure if I still need the same engineering education that I benefited from 35 years ago, but we need the experts that can actually check what the AI model does. And I really like
I
Sylvia.
think that's fundamental. Yeah.
AI has many teachers, and we need to look at the teachers. I also like somewhat related this analogy, like AI is typically not your world-class expert, but it's for sure a pretty capable and very hardworking intern. And an intern, you
I
actually
like
want
that.
to
Yes.
double check what your intern comes up with before you present it to your management. And that's the same here.
Absolutely.
So that's about the people. And the other thing that I want to say, and this is going to be quick, um, we need to move on from this idea that AI is just a push of a button. We don't need to do anything. So it really is a companionship. It is an AI aid. AI actually is the beginning of the word aid. So therefore, this is how we should see it, that it's not just you push a button, you don't need to do anything else. After all, I mean, hey, we also want to do some work because we don't just want to be replaced like that.
Absolutely. So just to top it all off, we have a question here. What's the one technology that all sectors see as critical and that all three sectors could potentially, but realistically, collaborate on? Sylvia, what do you think?
Oh, I think that I can return it to the AI. I really think that we can use in parallel, and we can use the base data, the base structure of that to work in tailoring things that we need to do, that we need to develop. But I really think that's important. I really appreciate your comments, Van. And we needed to see that AI is really a tool. And as a tool, we needed to validate this. We needed to confirm it. And sometimes I made some tests. I asked something to AI, and when I saw the answer, sometimes I think, oh, I agree with you, but I disagree in this point. And
Mhm.
we needed to train in that. And I think that we can train in that in our different areas, because we have a lot of specific points to address to our
Yes,
specific customers in our specific applications. But
yes,
we can use this basic technology.
agreed. Yes. Samir, what do you think?
So I think in terms of a critical technology which overlaps across all the three sectors, I would say would be anything that can produce genuinely valid data. And I think that one thing that comes to mind is IoT devices, something which can be used I think
Yes.
begs the question that if we can have good data, because your AI algorithms is only going to be as good as the data that you're providing.
Mhm.
Any type of technology which can help us fill in the gap of existing systems. So before we can actually apply AI, before we can actually start developing digital twins, or any high fidelity simulations, there's always going to be a need for this type of technology. So we've been trying to use AI to fill this gap to a certain extent as well. Uh, and traditional engineers might be using something like common filters or other estimators to do some sort of virtual sensing. But I think any type of technology which can give you a good data source will be critical, because that's just what your asset's going to be. And like I mentioned before, data is like your new oil. That the amount of data you have is the more critical decisions you will be able to make, the more safe,
More informed, right?
cost-effective systems you will be able to make. If you don't
Yes,
have the data, you won't be able to do anything.
you're right. Sven.
Yeah, let's see. I mean, it seems like we all can agree on AI, software, and data. So I will not repeat this other than just saying that I very much agree with Sylvia and Samir. But maybe let's just add a little bit. What is then number, what have you, 4, 5, and 6? And we have not talked at all about energy efficiency today. And
Mhm.
therefore, I will say it is certainly something electrification that I think unites and cuts across our three sectors that we are discussing here, like energy storage systems, so next generation batteries. Hydrogen is a topic in all three sectors that is, I think, very, very important, and also lightweight structures. And I don't
Yes.
know that much about commercial vehicles, but I see Sylvia nodding. Maybe in the past you said, well, a truck is heavy, so what? But now, as we are putting like heavy batteries on a truck, we maybe don't want the frame to be still as heavy, because that is eating up more and more out of our payload. Same on a flying vehicle. I mean, that has always been the leader in lightweight materials. So there's maybe something that we can exchange, cross pollinate even more going forward. So that
Agreed.
these are like the next ones that I would definitely mention after AI and data software.
Definitely. And these are good ideas for future mobility frontier webinars.
Take it.
Yes, thank you. Thank you all so much. This, as we intended, was fun, was productive. Thank you for coming. Thank you to the audience who was there with us. I would also like to thank Matt Wazowski, Marcy Heineman, Gwen Geyser for all the support. And we'll see you again in the next Mobility Frontier. I'm Monica Noguera, Director of Content Acquisition and Development here at SAE International. Until next time.